not miss, okay? We use this daily in BC. What's wrong, Evangeline?
When is the homework due?
When is the homework due? Mondays.
How long do we have?
Monday.
Until Monday?
Till Monday. But remember, that's your extra credit points. We're going to switch it in a few weeks. Once I'm done with the book curriculum, then I'm going to switch that rule. Okay? All right? But I want keep up on it, right? I know we still have games. I know we still have other parts of our lives other than just calculus, right? My expectation for calculus is going to get really high in a few weeks, though. Okay? So you want to keep up. All right? All right, so we're going to talk about this thing called integration by substitution, okay? So the integration we've done so far is very limiting in what we can do with it, okay? Remember how we had the chain rule, okay? And we had the product rule and all those other rules when we did derivatives. This is kind of taking the place of that in the integral world, okay? So we're going to do this thing called substitution. We're going to spend a couple of days on it, okay? It's something you really need to know how to do, all right? Like I said, we use it pretty much every day in the second year class. So you should be getting really good at it, okay? All right. So you don't have any, no, we're not writing that down. We're just going to read it, okay? So the chain rule allows us to differentiate a wide variety of functions, but we are able to find antiderivatives for only a limited range of functions. We can sometimes use substitution to rewrite functions in a form that we can integrate. You guys, and for our part of calculus that we're responsible for, we only take you through part of the integration world, okay? We take you through a much bigger part of the integration world next year, and then the year after that, they do like multiple integral symbols in a problem, okay? That's multivariable in calculus. We're not going to be ready for that for a couple more years, okay? But we're only seeing a very small snapshot of integrals in here, okay? All right, so we got to find the indefinite integral on this. This one I did steal this presentation from another teacher long time ago off the internet. So it's partially animated, which I thought was nice, okay? So some of it's animated, some of it's not. All right, so there's your problem. Do you see how we have a function inside of a function? So it kind of looks like a chain rule kind of a thing, right? But so we've got to be able to integrate that. There's no way that I'm going to expand out to the fifth power, okay? Especially since last year I didn't teach you the shortcut on how to do that because we ran out of time, okay? There is a shortcut. Maybe at the end of this year I'll teach it to you. All right. So what we're going to do is we're going to do what we call substitution. So I'm going to take this piece of this function that's on the inner function. I'm going to let it equal u. So write this down. U equals x plus 2. Okay? Now, if I'm going to substitute that in, and if I'm going to put u's into the problem, I'm not allowed to have x's in the problem. So I'm going to take the derivative of this function here. So what's the derivative of u? Well, it's 1 du, right? And then what's the derivative of x plus 2? 1 dx, right? So we're going to say that it is du equals dx. So we are going to write down the du dx part. Okay? All right, so let's go ahead. We're going to substitute in. So for this piece here, I'm going to put a u in for it. For the dx, I'm going to put in the du. So the u goes in for the x plus 2. The du goes in for the dx, right? Because that's what it was equal to. You don't need to write the arrows and all the words. Okay. All right, now that looks like something we know how to integrate based on what we've been integrating since before Christmas, right? So when I integrate u to the fifth, I add 1, so what's my new exponent? 6. I divide by the new exponent 6 plus c, right? That's another way to write it. We tend to write the 6 in the denominator, and that's fine. You can write it that way. All right. Now that we've got that, the problem is we started in x's, right? So we need to end in x's. So I'm going to take this u that I had, and I'm going to substitute it back in for this u. So I'm going to plug the x plus 2 back in for the u. So x plus 2 to the 6th over 6 plus c is what this integrates to. All right, let's do another one. This one's not animated, okay? All right. What looks like the inside function? Good, so that's your u. All right. Then I'm going to take my derivative. So du equals what? Dx. And remember, we're doing very, very simple today. Okay? This gets more complicated as we go. Okay? So I'm showing you the basics. All right, I'm going to pull that 5 out front. Really doesn't have much to do with the inside of the integral. We know we're allowed to do that. It's one of our rules. That's my u, right? So I'm going to plug u in for that to the 4th power. What do I plug in for the dx? du. Perfect. All right, now it looks like something we know to integrate, so we're going to go ahead and integrate that. I get u to the 5th over 5 plus c. Good. What happens? 5's cancel. I'm not going to rewrite it just to plug something into it. So I'm going to go ahead. We're going to plug our u in this next step. What am I putting in for the u? X plus 3 to the 5th plus c. Not so bad, right? Okay. The next one's a little bit different. Okay? So, this is a little bit more complicated this time. What looks like the inside function? Perfect. Okay, so 16 minus x cubed. Because even the simplistic ones I just showed you, they only can take us so far. Okay? So let's take the derivative of this over here. So what is the derivative of u? Du. The derivative of 16 minus x cubed is? Dx. Okay. So you notice how we have that x squared hanging out? Okay. Whatever I have over here, whatever I get when I take the derivative should be hanging out in my function. Okay, so let's look at this. It's okay. It keeps falling down. All right, so do you see how I've got x squared and dx? So I got that when I took the derivative. What did I not get? The negative 3 isn't over here anywhere, is it? So we have to kind of add that in, because in order to substitute in du equals this. So, or I have to get it just as x squared dx. Just let it go. Okay? I will rehang it up later. So I'm going to take this with negative 3 and I'm going to move it to the other side by dividing. So it becomes negative 1/3 du equals x squared dx. All right, now let's substitute in. Okay? So what goes in for the 16x minus 3? U, and it's squared because of the function. For the x squared dx, what does it say x squared dx is equal to? Negative 1/3, which is a coefficient, so we throw it out front. Du, I throw a 1 on top of this. Okay? So again, the reason I had to move this was I had to isolate the x squared dx because that's what I had to substitute in for. Okay? All right. We don't like that. We want to move it upstairs in order to integrate it, right? And some of you at some point are going to do a lot less steps. Okay, but it's the first day. What do I have to do to the exponent? Negative. Excellent. All right, let's integrate. So u to the, when I add 1, what do we get? Negative 1. Divide by negative 1. What's that going to just do to this? Make it positive. Okay, plus c. Good. All right, I'm going to bring this u back downstairs, so I really have 1/3u plus c. And what do I still need to do? Yeah, you got to plug your u back in, so 1/3 16 minus x cubed plus c. All right. There's another one. That's what? We've got 3 more? 4 more. Still. Okay. We'll go up to 7? Or to 8? 8. Oh, we've got 6 more. Okay. Let's keep going. Alright. So, this one's animated again. Alright. What do you think what's your inner function here? 4x minus 1. So, write down u equals 4x minus 1. You don't need to write the word let. Okay, so we gotta take the derivative. What's the derivative of u? Du, what's the derivative of 4x minus 1? 4dx. Okay, so here's the thing. Do you see how I have the dx? Do I have the 4? Not outside the radical, because this is going to get substituted with the u, right? So I have to move that 4 to the other side. How do we do that? Divide it. So we're going to end up with 1/4 du equals dx. So they're going to have a little thing here that says solve for dx. You don't, unless you want to, you don't have to write that down. Okay, remember this is like saying to the 1/2 power. Okay, so when I substitute in, what am I going to put in for the 4x minus 1? U. Okay, and then for the dx part, I'm putting in 1/4 du. Now, the way that this guy did it, he left it on the inside. There's nothing wrong with that. Yeah, write it like how I would write it. If you guys want to write it as 1/4 u to the 1/2 du, perfect. Okay. All right. So when we go to integrate, we're going to add 1 to this exponent. What does that make the new exponent? 3/2, and we're going to divide by 3/2 or multiply by reciprocal, which is 2/3. The 1/4 is still going to just be a 1/4, and we got to add plus c. All right, can I do some canceling there? Yeah, what goes away? 2 into 4 twice. So could I simplify that a little bit? Isn't that 1/6? So 1/6 u to the 3/2 plus c. We multiplied the 3 and the 2 in the bottom. Okay. All right, and what do I still need to do? Plug your u back in. All right, we good with 4? Okay, let's try again. Okay, trig is great for these. Okay, pretty much almost every trig problem you're going to do. Because if not, it's just integrate. It's the 6 memorized ones, right? So this really lends itself to the trig problems. All right, what's your u? 7x plus 5. It's got to be, right? Whatever's on the inside. All right, what's du? 7dx. All right, we have the dx. What are we missing? The 7's missing, right? And if it helps you, highlight or underline what you have that matches. Okay. All right, I got to move that to the other side. How do we move it to the other side? Divide it. Perfect. It's like the neatest my handwriting has ever been, right? All right, let's go ahead and sub in. And again, remember, this guy who wrote this is gonna keep the 1/7 inside. If you want to put it outside the integral symbol, that's fine. Okay. All right, so cosine, what am I gonna write in for this? U. And then for the dx, we're gonna put in the 1/7 du. And again, you can put that 1/7 in front. Okay, so again, this came from substituting in my dx. All right. When we integrate cosine, what do we get? We get sine, so the 1/7 is going to hang out, sine u plus c. All right, and then what do we sub in for the u? 7x plus 5. So 1/7 sine 7x plus 5 plus c. All right, it's going to get a little bit uglier. Okay, a little bit, not too bad. We've already seen one that's kind of like this. This one has a lot of writing on this slide, okay? So one of our clues that we look for is that to tell us that we're doing u substitution is that of the inside function, the derivative appears. Do you see what's the derivative of x squared? 2x. See, it's sitting there? That's a clue that we're doing u substitution. It also helps us find the u, okay? So what are you going to say your u is? Oh, they're already telling you. Well, u is going to be the 1 plus x squared, right? So write that down. So this is what you need to write. Write that line right there. U equals 1 plus x squared. All right. What is the derivative of, what's du going to be equal to? No? 2x dx, right? And that's important because don't I have a 2x dx here that I have to have it equal to? I have to be able to sub into there. If you still have x's left behind once you've done your substitution, something is wrong. Or you have to fix something else. And we're going to see one that's like that. I don't know if it's today, but by tomorrow or the next day we might. All right, remember that's a 1/2 power, right? So what am I subbing in for the 1 plus x squared? U. Okay, and then for the du, or for the 2x dx, I'm just subbing in du. So 1/2 is this piece, or the u is that piece, the du is this piece. All right, let's integrate it. So I add 2 over 2 to it. Okay, so what do we get as our new exponent? 3 over 2, and then divide by 3 over 2 or multiply by? Reciprocal 2/3 plus c. All right. What do I still need to do? Plug in u. Okay. And so we get 2/3 times 1 plus x squared to the 3/2 plus c. Now he's going to put the little note up here. We're going to read through it. Don't write it down. Okay. This only worked if because the 2x in the original was there. Okay. If I had done this and I had used this as my u, and that 2x wasn't there, I couldn't use u substitution on it. There would have to be another technique. Okay, or we wouldn't be able to integrate it. Very few of them we don't integrate. Okay, all the ones we're going to give you have u substitution? Absolutely. Okay, we're not going to give you tricks at this point. Okay, so we want you to practice the u substitution. All right, so let's try this one. We got to throw some trig in there. All right, again, you're looking for that inner function. What's the inner function? Just the x cubed is on the inside, because isn't this kind of like a product there? Yeah, so the inside function is the x cubed, so we're going to let u equal the x cubed. All right, what does du equal then? 3x squared dx. Don't forget the dx part. So I want you to look at your original, what you have there. See how we have an x squared and a dx? What are we missing? The 3. And see, if that underlining helps you, do that. Okay? This part, this u substitution, is not on the free response part of the AP test. It's only on the multiple choice. Nobody's going to see you underlining things. Okay? All right, so we're going to go ahead and move the 3 over by dividing. So 1/3 du equals x squared dx. Okay, and he's going to pop up a little note there. You solve for x squared dx because we can find it in the integrand. All right, so what are we going to put in for the x cubed? U. And then what do we put in for the x squared dx? 1/3 du. Good job. He put the 1/3 in the right spot this time, didn't he? All right, so we're going to go ahead and integrate. When we integrate sine, be very careful. What do we get? Good job. Plus c, right? So the 1/3 hangs out. All right, what are we going to plug in for the u? X cubed. Good job. All right, we good with 7? I don't know. It's noisy out there today. Normally it's not that noisy this time of day. Oh, it's raining. Yeah, the people are concentrated in places, aren't they? All right, looking at this one, it looks awful, right? Let's rewrite it. Whenever you see this, it's hard to tell what the inside function is, right? But remember, we're allowed to write our trig like that. Sine x in parentheses to the 4th cosine x. Okay? So in this case, what's the inside function? Sine x. So we're going to let u be sine x. Now, I know that cosine x is freaking you out right now. Okay? What's the derivative of u, though? Du equals cosine x. Do you see how it popped out? Okay, so the derivative of the inner function was there. All right, so what do we get to substitute in for the sine x? u, and then the cosine x dx we put in du. So we get u to the fourth du. All right. Well, we're gonna go ahead and integrate. We have to add 1. So when we add 1, what do we get? 5 divided by 5. He's gonna write it 1/5 u plus c. What are we gonna substitute back in for the u? Sine x. And he's gonna write it the fancy way. Sine to the 5th x. If you want to write it like this and it looks like this, that's okay too. Just make sure you have the parentheses so that 5 does not end up on the x. Oh, there's 9 today. Wow. Okay. Last one. This one's weird. This one's weird. Okay? This one's got a weird trick to it, but I want to make sure we do it because it might pop up in the homework. Okay? Alright. So we need to find the indefinite integral by the method shown in example 5. I'm not sure why they say example 5. This is example 5 in your book. Okay? So maybe maybe this is the example that is example 5. I don't know. Alright, so what looks like the inner function here? So u equals 2x minus 1. I'm going to do something weird with it because I'm going to have to do something with this u in a minute. I'm going to go to du to the right of it. So what's du going to be equal to? 2 dx. Which I have the dx. What am I missing? The 2. And something else weird is going on, right? Because we didn't get that x to pop out. So I know I've got a 1/2 du equals dx. I'm going to show you how to deal with that. Okay? I only show it when it's necessary, right? That's kind of how I've always been, is we don't solve for something until we really need to, right? So there's a purpose for it. All right, so I know that this is a 1/2 power. What's going in for this piece right here? U, so I've got u to the 1/2. For the dx part, I'm substituting in 1/2 du. And then there's that x. So here's the thing, I need to turn that x into a u. Couldn't I solve for this and figure out what x is equal to in terms of u? That's why I left the space under it, okay? So I'm going to go ahead and move the 1 over. So u plus 1 equals 2x. So what's x equal to? Good. From here on out, it's fancy algebra. Okay? So now this is going to get substituted in for the x. Is every single problem going to be like this one on the homework? No. Most of them are going to be the easy ones. Okay? But I don't want to leave you hanging on the hard one. Okay? Alright. Let's do some fancy algebra and make it more solvable for ourselves. Okay? I'm going to take this and I'm going to group it out front with that 2. So I really have 1/4 out front. So that brings it down to u plus 1 times u to the 1/2 du. Couldn't I distribute this in? Yeah, so, and remember, this is like saying 2 over 2, so I have 1/4 u to the, what's 2/2 plus 1/2? 3 over 2 plus u to the 1/2 du. Just so we remembered that the exponent was 1, right? And we wrote it with a denominator of 2. If you can do that in your head, do you really need to do that? No. Okay. Alright, we are going to go ahead and add 1. So instead of adding 1, we're really adding 2 over 2. So I'm going to have the 1/4 hanging out. U to the what power? 5/2 divided by 5/2 or multiplied by reciprocal 2/5. And then I'm going to add the 2 over 2 to this one as well, because that's my 1, right? So I get u to the 3/2 divided by 3/2 or multiplied by reciprocal 2/3 plus c. It looks horrible, but what's our last step? What do we still have to do? We got to plug it in, right? Once you've plugged it in, you've got it. The book may simplify it more than this. I probably wouldn't. Okay? 2x minus 1 to the 5/2 plus 2/3 times 2x minus 1 to the 3/2 plus c. Okay. All right. That's it for today. You do have the homework posted in haiku. Okay, so let's get that written down and taken care of. If you want stamps, you know you're welcome to come see me whenever you're ready for that. Yes, Jordan. You can keep going in your same homework notebook. That's fine. Until you run out of space in that one.